In this lecture, we will learn how to implement bridge design pattern in Angular, and this will be a practical example. We are not going to showcase those academic examples, and I am not going to showcase the diagram or definition. We will just see the problem in our code and we will try to fix it, and naturally it will become the bridge design pattern. I write blog on Medium, and this is my Medium handle, and today we will learn this pattern through this blog only. Okay, so let's get started. So here you can see we have two components, customer component and vehicle component, and in this component we have a common footer. This footer contains save, discard and refresh button, and the vehicle component also has the save, discard, refresh button, and this footer is repeated in customer and vehicle. The reason is when we click on the save button, discard button or refresh button, it handles the event related to the customer. For example, if I click on the save button, then it will save the customer data there, and if I click on the discard, then it will reset the customer form, and when I click on the refresh, it will call the customer get APIs. Similarly, this is for the vehicle component, and when we click on save, discard and refresh button, it is respectively going to call the vehicle APIs. Now let's see what are the problem in this code. So first of all, the HTML and CSS is repeated, right? So in the customer and vehicle, the HTML related with this footer buttons and the CSS both are repeated in these two components. Secondly, it is violating the dry principle. Dry stands for don't repeat yourself, or in the software world we can say if the code is repeated then abstraction is needed, and if the process is repeated then automation is needed. So clearly we have the problem of repetition of the code, and we surely need some abstraction, and finally that will be the bridge design pattern. So we will see later. And the third problem is maintenance nightmare, and this is because the repetition of the code. Suppose we want to add one more button, then we will have to add here in the customer component as well as the vehicle component, and HTML and CSS will be again repeated in both the components. Okay, so again I will showcase what is the problem. Here we have three button: click, handler, save, discard, refresh, and in the customer it is going to call the customer API, in the vehicle it is going to call the vehicle API. And as I already said that HTML CSS repeated maintenance is a problem. Now how do we fix it? So we are going to fix it. We are going to create a reusable footer component, and we will expose some output event emitters. Right now here the footer has a separate component f footer, and the repeated HTML and CSS will become part of this footer component. And here when we click on the button, we are going to emit the API to the parent, right? So this event emitter will emit the value that yes, the save button has been clicked, now you do the operation. Now if parent component is customer, then we will handle the event emitter in the same way. Save, discard, refresh of the customer will be called, and similarly in the vehicle component from the footer, when the save button is clicked, we are going to handle it into the vehicle component. Now let's understand what is the problem in this code. So the first problem is prop drilling. Now prop drilling means passing the input or output properties to deeply nested component. For example, from parent to child to the grandchild until we reach the desired component, and the intermediate component just pass that value. For example, if it is input, then they will pass the value until it reaches to the desired component. So here again we can see here we have the problem of prop drilling. We can, if there is nesting, then footer will pass its parent, then in the parent save method we are going to again emit the value until we reach to the desired component, which is vehicle and customer component. Now second is footer is a dump component. Right now in the footer code you see that it is doing nothing. When the save button is clicked, it's just emitting the value to the parent and nothing else. And the third problem is boiler code. Every parent must wire up the same 3 event bindings. All right, so what could be the refactoring? So imagine if we have customer component and vehicle component in our footer component, correct? What would we have done? When we click on the save button, we check if it is a customer component, then we are going to call the save method of the customer. What if it is a vehicle component? Then we are going to call the save method of vehicle component, correct? Similarly, we can implement the discard method and refresh method. Now let's see what is the problem in this code. Now this code is violating two principles. For example, if one more component comes into play, then we will have to inject that component in the constructor of footer component here, like product component. Then we will have to inject here, and in the save method we would add one more condition if, and then we call the same method of that component. Similarly, we had done for discard and refresh. Now if you have heard about open close principle of solid design principle, it says that the class should be open for extension and close for modification. Now if one more component comes into play, this class is being modified. It is violating one more principle, which is D of solid design principle. D stands for dependency inversion, and it means low level module should not depend upon the high level module, and high level module should not depend upon the low level module. Both should depend upon the abstraction, and abstraction should not depend upon the detail. So here you can see our low level module is depending upon the high level module right here. So it is depending upon the customer and vehicle. Why? Because we want to identify which save we want to call, right? So the it is depending upon the detail, right? We must know what is the component first, and then only we are going to call the method, right? Now this is not the correct approach. So this low level module, which is footer component, should depend upon the abstraction. Now let's see what abstraction we can do here. Now solid design principle says that high level module should depend upon the abstraction, low level module should also depend upon the abstraction, and the abstraction that we have created is ifooter. Ifooter will abstract away these 3 methods: save, discard and refresh, and it will be implemented by high level modules and low level modules. So here in our case, footer will be implemented by the footer component as well as the vehicle and customer component, and the abstraction will be injected here in the footer component. Now we will assume that somehow the dependency injection will do the mechanism that it is going to inject the ifooter. Since ifooter is implemented by the all the parent components, which is vehicle and customer, so we can get the reference here. And when in the footer, when we are going to click on the save button, we are going to call the save method of the parent, right? So dynamically it will be either customer component or vehicle component, and based on the component's context, when we click on the save, discard, refresh button, it will call its parents save, discard and refresh methods. But the problem is the interface doesn't exist at runtime. There is no concept of interfaces in the JavaScript. This is the concept of TypeScript, where we can declare the interface, but at the runtime, when this TypeScript is compiled into JavaScript, then these interfaces doesn't exist. So for that, Angular has provided a mechanism which is injection token. So if we have footer or a object, we can provide them as a injection token. So what we are going to do, we declare the ifooter interface, and we are going to create an footer underscore token. So this is an injection token which will be of type ifooter, and we provide a string value here which will make this token unique, right? Now let's see how the footer components implementation had changed. Now in the footer we are going to inject footer token, right? And this will have the reference of parent component. It can be either customer component or vehicle component or any other component which will implement the ifooter. Also this footer component is going to implement the ifooter. Since ifooter has three methods, save, discard and refresh, we are going to implement those methods, and in this method, based on the context, we are going to call the save, discard or refresh method of the parent, right? Now so footer is fixed. Now let's see how do we wire up into the parents. So first of all, the parents will implement ifooter because D, which is dependency inversion of solid design principle, says all the modules should depend upon the abstraction. So the parent should be called as ifooter. Secondly, we are going to provide the footer token in the parent. Now this is how we are going to provide the footer token in the parent. We write provide footer token, and then we are going to use the providers. So there are four type of providers: use class, use value, use existing, use factory. So here we are going to use existing. It says that the already existing component will work as a footer token. Now let's understand how the dependency mechanism work. Here the app footer is child of this customer component, correct? Now in the app footer component we have injected this footer token. Now it will ask, give me the dependency whose name is footer token, correct? Now it will look into the providers array of this app footer component. Do we have declared here? Nothing. So it will go to the up to the parent. Now parent is customer. Now in the customer it will ask, do we have footer token here? Now we have declared here that whenever you ask footer token, this component will act as a footer token, right? So in the customer component, footer token will be the customer component, right? So here automatically the parent, which is customer component, will be injected when the app footer is declared in the customer component. Similarly it will happen with the app vehicle. In the vehicle we also we will provide the footer token, and use existing will be the vehicle component. So we will be able to, now what will happen, this is implementing the ifooter interface. So these will remain same. The implementation of vehicle and customer component will remain same, and footer component automatically, with the help of this dependency injection, it will get the reference of the parent. So when the footer component is declared into the customer, then it will have the reference of customer component. When it is declared in the vehicle component, then it will have the reference of vehicle component, and on the click of button we are going to call the method of the parents component. Now with this approach we are done with the refactoring, right? And this implementation that we have refactored is known as the bridge pattern, right? So whenever a new component comes into play, for example product component, we are going to inject the footer token. We are going to provide it here, and this product component is also going to implement the ifooter, and then automatically the footer will take care of those things. Now if you want to understand the diagram, now the things are very much clear. So we have created an abstraction ifooter. Ifooter is implemented by the concrete implementer, which is customer component and the vehicle component, and also it is implemented by the footer component. Apart from it, this footer component will compose, or the abstraction will be injected into the footer component. All right, so I think the diagram is also clear and bridge pattern is also clear. I hope this session was wonderful. So let's meet into the next lecture.